Welcome back to Knowledge Bytes. In our previous episode, we learned about the perceptrons, weights and biases, and activation functions. Today, we will answer an important question: How does AI learn, and how does AI makes predictions? The answer comes down to two phases, that is, training and inference. Training is where AI learns. Inference is where AI uses the knowledge. Every AI application from the ChatGPT to Netflix and Alexa depending on these two phases. Let's understand them in the simple example. Now, let's imagine a student preparing for an exam. The student reads books, practice questions, makes mistakes and improve over time. These learning phases is like training. Now imagine exam day. The student used what they learned to the answer questions. So this is like inference. Training is learning, inference is applying what learned. So AI works exactly the same way. Next, so training is a process where an AI model learns from the data. The model receives examples and tries to make predictions. At first, many predictions are wrong. The model compares its predictions with the correct answers. Then it adjusts its weights and biases. This process repeats thousands or even millions of times. The goal is simple: reduce errors and improve accuracy. That's training. So training follows a simple cycle. First, data is provided. Next, the model makes a prediction. Then the prediction is compared with the correct answers. The model calculates the error. It updates its weights and biases. Then the cycle repeats. Over time, the model becomes smarter and more accurate. So look at this real world example. Suppose we want to build a spam detection system. We provide thousands of emails labeled or spam. So labeled as a spam or not spam. Then AI studies these examples. It learns patterns such as suspicious words, unusual links, or unknown senders. Eventually, the model understands what spam looks like. Now it can identify new spam emails it has never seen before. That's the power of training. Once training is completed, we move to the inference. Inference is the prediction phase. The model is no longer learning. Instead, it uses the knowledge to make predictions on the new data. For example, when a new email arrives, the model predicts whether it is a spam or not. The predictions happens in milliseconds. That's inference. Let's compare them. Training teaches the model, inference uses the training model. Training uses historical label data, inference uses new unseen data. Training takes time and requires powerful hardware, inference is fast and lightweight. Training builds knowledge, inference delivers results. A simple way to remember: training learns, inference predicts. Training and inference work together. Training builds intelligence, inference uses intelligence. Training learns from the past, inference helps make decisions for the future. Whether it's medical diagnosis system or fraud detection system, self-driving cars or recommendation system, the same process applies. First training and then inference. Inference is all around us. ChatGPT generates the response, Netflix recommends movies, Amazon suggests products, Alexa responds to voice commands, and Face Unlock recognizes your face. These systems aren't learning every second. They are using already trained models to make predictions. That's inference in action. Okay. So inference follows four simple steps. First, new data is provided. Second, the trained model analyzes the data. Third, the model predicts the most likely outcome. Finally, the result is returned. The entire process often takes less than a second. This speed is what the AI useful. So now, there are different types of inferences. Batch inference processes large amount of data at the scheduled time. Real-time inferences makes predictions instantly. Edge inferences run directly on the devices such as smartphones. Online inferences continuously adapting using new data. Different business use cases use different types of depending on their needs, right? So now let's get into the next one. To get the best results from the AI, use quality data. Choose the right model, optimize for the speed and scalability, monitor performance regularity. Also, watch for challenges such as the latency, data drift, and privacy concern. Successful inference requires more than just the good model. It requires continuous improvement. Let's test your knowledge. A trained model receives a new image and predicts whether it contains a cat or dog. What process is happening? Right? The answer is inference. The model is not learning. It is simply making the predictions. Remember, training is learning and inference is prediction. Next example, another one, right? So the company generates the millions of recommendations overnight. Which type of inference is this? The answer is batch inference, because through the batch inference the millions of records can be processed. Now, another example. Alexa receives a voice command and responds immediately. This is real-time inference, quick memory trick, because batch equals scheduled, real-time equals instant, edge equals device, online equals continuous adaptation. Key takeaways. Let's recap. Training is the learning phase, inference is the prediction phase. Training uses historical data, inference uses new data. Training improves the model, inference delivers the result. Training teaches, inference predicts. That's the most important concept from the today's lesson. Congratulations. Today we learn what training is, what inference is, how both work together, real-world example, type of inference, and the AWS exam-style questions. In the next episode, we will start learning the convolutional neural networks, that is the CNN. You will discover how AI recognizes the images, faces, and objects. If you enjoy this video, please like, share, and subscribe. Thank you for watching. I will see you in episode 11. Thank you.